Welcome to today's class. My name is Mr. Femi Folorenshaw, and in this class, we shall be looking at the topic relative molecular mass, also known as RMM. Our understanding of how to calculate the relative molecular mass of a molecule shall be the priority of this lesson.
Lesson objectives for today's class is 1. To define relative molecular mass, 2. To identify symbols and atomic masses from the periodic table, 3. To calculate relative molecular masses of simple compounds. Then we also apply the concept to real chemical substances. The lesson objectives for today's class is 1. To define relative molecular mass, 2. So let's dive into the topic of the day, and we are going to be looking at the meaning of relative molecular mass, which is the sum of the relative atomic masses of all atoms present in one molecule of a substance. I'll take that again. The sum of the relative atomic masses of all atoms present in one molecule of a substance. For example, let's say we have a common salt, the salt we use at home, and in this, the common salt, the name is sodium chloride. We have the sodium and we have the chlorine atom joined together to form that compound. Now, if you know the mass number of sodium and the mass number for chlorine, when you add up these together, it will give us the mass of 1 mole of that sodium chloride. That's what relative molecular mass is. Molecule and mass, that means you have two or more elements chemically combined together, which we shall see shortly. And before we go into that, let's look at the formula. The formula remains mR, relative molecular mass. We can use a short form to represent it as what mR, which is the sum of atomic masses of each element times number of atoms. All right. So, having known the definition of relative molecular mass, let's look at the definition of relative atomic mass. But before we do that, let's remind ourselves the definition of atoms again. We said atoms, they are the smallest particle of an element. Atoms are smallest particle of an element, and now these atoms, they combine together chemically to form a molecule. So we define molecule as two or more atoms chemically bonded together. It must be two or more than two atoms that are what chemically bonded together to form a molecule. And so the reason why we define this, remember from our topic we said relative molecular mass. That's why because we are looking for the mass of a molecule, so we must know what the molecule is before we can look for the mass. And now we look at the relative atomic mass, which is the AR. Relative molecular mass is mR. Relative atomic mass is AR. I take it again. Relative molecular mass mR. Relative atomic mass AR. And this relative atomic mass is defined as the average mass of an atom compared to 1/12 of carbon-12 isotope. The average mass of an atom compared to 1/12 of carbon-12 isotope. Why do we choose carbon-12 in the definition of the relative atomic mass? Now, carbon-12 is a stable element. It is what? A stable element that is non-radioactive, and it is most abundant. You can see it in so many compounds, and by that we can compare, since it's stable, we can compare its mass with mass of other elements. So with a method or with the method of spectrophotometry, the mass of elements are what calculated in comparison with that of 112 and carbon 12 isotope. And now, from our periodic table, we can identify the mass number, which is the relative atomic mass, and also the atomic number, which is the number of protons present in the nucleus of an atom. For example, this chlorine, which is 17, this is 17 as the atomic number up there, and 35.5 as the relative atomic mass. So in periodic table, check out for these numbers so that you can use it to calculate your relative. The relative molecular mass has no units. It is a ratio comparing the mass of a molecule to 1/12 the mass of one atom of carbon 12. So when you calculate the relative molecular mass of a substance, you are not expected to put any units because it is a pure number. It is a digit. Since we are comparing the mass of one atom or mass of one molecule to the mass of one atom of carbon 12, so you are comparing two masses. So the masses will cancel out. It has no unit. So having said that, the relative molecular mass has no unit. However, when we use it to find the molar mass of a substance, we are expected to put a unit. So molar mass of a substance has units, and the unit is grams per mole. So in a question, if you were asked to find the relative molecular mass, mind you, don't put units. But if you were told to find the molar mass of the compound, please add the unit. The unit is grams per mole. So for water, the molar mass of water is 18 grams per mole, while its relative molecular mass is 18. All right, here are some examples of calculations. And the first questions we have is calculate the relative molecular mass of water. We have some steps to take. The first one is to write the correct formula of water. And we know that the formula of water is H2O. Having done that, then we go ahead to identify the elements and the numbers of atoms of these elements that are present in the formula. H2O, we have two hydrogen atoms and one oxygen atom, meaning we have element hydrogen, element oxygen. Hydrogen appears 2 times, while oxygen is just 1. Then the third step to do is to write out their AR, that's the relative atomic mass for the elements present. For hydrogen, it is 1, while that of oxygen is 16. And now we can substitute these values into our formulas by saying Mr, which is the relative molecular mass of the compound, is equal to 2 times 1, 2, the number of hydrogen atoms, times 1, 1, it's AR, that's relative atomic mass. Then we add it up with that of oxygen, 1 times 16, 16 being the AR of oxygen, and 1 being the number of times oxygen atom appeared in that formula H2. By doing this, we add up 2 plus 16, we will have 18 as our final answer. So the relative molecular mass of water is 18. Okay, let's look at example 2 now. If we are asked to calculate the relative molecular mass of calcium carbonate, then we can follow our previous steps too. For example, calcium carbonate has the formula CaCO3, right? I believe you still remember this, you know. Now, the Ca, from this CaCO3, how many elements do you think we have in this formula? Yes, okay. 3, we have 3 elements, and they are what? Okay, calcium, carbon, and oxygen. Now, having done that, let's identify the number of these elements in this compound. Now, we have one calcium, right? Okay, the second we have carbon. How many carbon? One. Good. Now, oxygen. Yes, it's 3 because it's carrying O3. So the number of oxygen in CaCO3 is 3, while that of carbon and calcium they are 1, 1. Okay, now the AR for these elements are 1. For calcium we have 40, for carbon it's 12, and for oxygen it's 16. So following our formula we have 1 times 40 for calcium, 1 times 12 for carbon, and 3 times 16 for oxygen. By the time you add up all of this together, you have 100. Therefore, the relative molecular mass for calcium carbonate is equal to 100. I hope you got that right. So, the importance of relative molecular mass include used to calculate moles of substances, help in determining chemical formulae, that's the chemical formula of substance, it helps us to determine it. Then it's also essential for chemical equations and stoichiometry. Chemical equations that we put on the board, it helps us to know how to put it down properly. Then we also use this in chemical industries for formulations. That's our industrial chemistry. They use it for formulations of compounds. Okay, having done so much on the topic relative molecular mass, and I've shown you some of the steps we can use to calculate the relative molecular mass. Here are some practice questions for you, and they are: 1. Calculate the RMN of methane. 2. Find the RMN of glucose. 3. What is the RMN of H2SO4? The last question is: why is it called relative molecular mass? Relative in quotes, relative in quotes. I believe you should be able to do these questions if you had followed the lesson properly. And I okay, there are some common mistakes to be avoided while calculating the RMM of a compound. The first one is the mistake that should be avoided is forgetting to multiply atomic masses by the number of atoms. Please don't forget to multiply the atomic mass by the number of the atom you have counted. The second is confusing AR with MR. MR is relative molecular mass, while AR is relative atomic mass. Relative atomic mass, you can get that number from your periodic table, while the MR, which is the relative molecular mass, you calculate it, and we have done that already. Using wrong atomic masses, that's why you have to make reference back to the periodic table if the number is not given in your question. So please check your periodic table for the correct number. Then adding incorrect elements. Please learn how to write your chemical formula. In some questions, the formula may not be written, so it's expected for you to write the correct formula down before you continue with your calculation. So, in summary, the relative molecular mass of a molecule is calculated as the sum of atomic masses of all atoms in a molecule. And this number helps in chemical calculations and mole concepts. And we are reminded that we should always refer back to the periodic table for accurate values. Now, in conclusion, I have some assignments for you, and they are displayed on your screen. Define the 10 relative molecular mass and molar mass in your own words. Why does the relative molecular mass have no unit? Why molar mass has a unit? Then the last question there is to calculate the relative molecular mass and molar mass of the following compounds: ammonia, glucose. The AR of these elements are given. I believe that you should be able to do this, and please do it. Practice more questions, more advanced questions than the simple ones. In our next class, we'll do well to revise some of